4.6 notes are about functions. A function has some special qualities about it. And for a function, each input has only one output. And most of what you're used to is a function. If I give you something into that function, it only has one possible thing that could come out. That's another way of saying each x only has one y that goes with it, not more than one y. Here are some visual representations of inputs and outputs. Determine whether the relation is a function. What you're looking for is, does each x value go to one and only one spot on the y side of the graph? -5 only goes to one spot. 0 only goes to one spot. 8 only goes to one spot. And 10 only goes to one spot. So this is a function. Each input has exactly one output. Pause the video and look at those two and try to decide if they are functions, yes or no. This one is not a function because this x goes to two different spots, so it's not a function. This one is a function. It's okay for the x's to go to the same spot. What's not okay is when an x, one single x, heads off in two different directions. It's okay if they end up at the same spot, that's fine, but it's not okay if we start at one x and go two different places. What about in the ordered pairs? Is that list of ordered pairs a function? What we're really looking for here is, are any of the x's repeated? And that would send the x's off in two separate directions. As I look at those x values, the x values do not repeat, so yes, that's a function. When you have a graph of a function, you can tell if it's a function or not, or when you have the graph of an equation, you can tell if it's a function by using the vertical line test. If a vertical line crosses the graph in only one spot at a time, if a vertical line crosses the graph in only one spot at a time, the graph is a function. Remember, for it to be a function, each x can only have one y. So if this vertical line test thing works, that's basically saying the same thing as each x only has one y. Take a look at these graphs. This first one, if I take my vertical line and move it across the graph, the vertical line is only touching the graph at one spot at a time. So this graph is a function. Each x value, no matter which x value I'm looking at, that x value only has one y. This x value only has one y. Every x only has one y that goes with it. On the second one, if I move my vertical line across the graph, the vertical line is touching this graph in more than one spot at a time. So that means this x value has two separate y's associated with it, and that's not allowed in a function. Now, when you're working on the homework, what you could use to represent the vertical line that I'm moving across, maybe a pencil, maybe just your hand, or maybe you're just imagining the vertical line moving across the page. Let's take a look at this one. Here, the vertical line's only touching one spot, only one spot, only one spot. But right there are two separate spots that are being touched at once. And because there's even one spot on the graph where the vertical line touches two places at once, no, this is not a function. That x has more than one y that goes with it. Function notation is the last thing in this section, and function notation is a short way of writing inputs and outputs. And what we do is instead of writing y equals, we're going to change that y equals into f of x equals. So we could rewrite this equation, y equals 3x minus 8, in function notation by just changing the part where it says y. If we're going to change that into function notation, instead of saying y equals, we're going to say f of x equals. The other side of the equation stays the same. F of x equals 3x minus 8. And I've said it out loud a couple times, but the way that you read f parentheses x parentheses is f of x. That f could be any letter we wanted, the f here sort of standing for function, but the functions don't all have to be named f. Functions could be named g or h or really any variable that we want. F is the name of the function that we're talking about, and then the variable in that function is an x. So it's f of x. How is this shorthand? So far it seems like the same amount of work. Well, some examples might make a little bit more sense. If f of x equals 2x plus 5, let's find f of 2, f of negative 2, and f of 1. When there's a number inside the parentheses, that's the number that we're going to plug in for x in the rule that we have. The rule, in this case, is 2x plus 5. So if I want to know what f of 2 is, f of 2 equals 2 times 2 plus 5. So that's 4 plus 5, or 9. F of 2 equals 9. Now I said it's kind of mathematical shorthand. Within that one quick and easy thing to write, what I'm conveying, or what I know from that, is when the x is 2, the y is 9. So this one equation, this one function notation equation, takes two separate equations and kind of puts it together into one easier thing. That's what I mean by shorthand. Instead of having to write a separate equation for x and y, it combines it into one thing where I can see the input and the output all at once. Let's try to find f of negative 2. We're still using the same rule, we're just changing the number that we put in. F of negative 2 equals 2 times negative 2 plus 5. So that's negative 4 plus 5, or 1. F of negative 2 equals 1. Pause the video and see if you can figure out what f of 1 is on your own. This time we're putting 1 in for x, so we're doing 2 times 1 plus 5. So that's 2 plus 5, or 7. F of 1 equals 7. The homework in this section is the 4.6 worksheet, and from the textbook in section 4.6, 18 through 28 even, and 29 through 35 all.